In this video, we're going to talk about sequences and series. First, we'll talk about a sequence. A sequence is an ordered list of numbers. And we have a finite sequence and an infinite sequence. As you can see, finite sequence has limited number of terms. Where infinite sequence, you have infinite number of terms. A finite sequence is a function that has a limited number of terms and whose domain is a finite set. 1, 2, 3, and all the way goes up to n. In this book, we're going to assume that the domain starts from 1. But in other books, they might start from 0 instead of 1. So just be careful with that. The values in the range are called the terms of a sequence. So the range will be like A1, A2, A3, and so forth. Now, a sequence can be specified by an equation or rule. For example, both sequences above, 2, 4, 6, 8, it can be described by the rule A of n equals 2n or f of n equals 2n. So for example, what is A of 1? When n is 1, it's going to be 1 times 2, which is 2. What is going to be A of 2, the second term? It's going to be 2 times 2, which is 4, and so forth. Now let's look at some examples. We have a rule or equation. A of n equals 2n plus 5. So what will be the first term? What will be the A of 1? Well, instead of n, you're going to substitute 1. So you get 1 times 2 is 2 plus 5, which is going to be 7. What about A of 2, the second term? Instead of n, you're going to plug in 2. 2 times 2 is 4. 4 plus 5 is 9. What about A of 3? 3 times 2 is 6. Plus 5 is 11. Now notice, each term is being increased by 2. So you know that A of 4 is going to be 13. A of 5 is going to be 15. And A of 6 is going to be 17. And so forth. So you have first 6 terms. What if you have f of n equals quantity 3, negative 3 to the n minus 1? What will be the first term? So we got to find f of 1. So instead of n, you plug in 1, you're going to get quantity negative 3 to the 0, which is going to be 1. What about f of 2, the second term? It's going to be quantity negative 3 to the 2 minus 1, which is 1. So you end up getting negative 3. What about f of 3? It's going to be quantity negative 3 to the second power, which is going to be 9. What about f of 4? It's going to be quantity negative 3 to the third power, which is going to be negative 27, and so forth. So it looks like you have to multiply negative 3 to the previous term to get to the current term. So these are first 4 terms of f of n equals quantity negative 3 to the n minus 1. Now we have a sequence. And how do we come up with the rule or equation of this sequence? Well, if you notice each term, we could rewrite this as quantity negative 1 to the third power, quantity negative 2 to the third power, quantity negative 3 to the third power, and quantity of negative 4 to the third power, and so forth. That's the pattern. So A of n is equal to, notice, we're starting with 1, right? So A of 1 is going to be quantity negative n to the third power. When n equals 1, it's going to be quantity negative 1 to the third power. What about when n equals 2? It's going to be quantity negative 2 to the third power. When n is 3, It's going to be quantity negative 3 to the third power. So here is an equation of this sequence. What about 0, 2, 6, 12? What is the equation or rule for this sequence? This is more difficult than the last one. It's not that obvious to find a pattern. But if you look at it carefully, right, you could say this is like 0 times 1. 0 times 1 is 0, isn't it? What about 2? 1 times 2. What about 6? 2 times 3. And 12 will be 3 times 4. And that pattern repeats. So if you look at 0, that is 1 less than 1. What about 1? 1 less than 2. 2 is 1 less than 3. And 3 is 1 less than 4, and so forth. So we could rewrite this as quantity n minus 1 times n, because that term is 1 less than this term. We could say that, let's see if a of n equals quantity n minus 1 times n, if it works. Does it? When n is 1, 1 minus 1 is 0 times 1. When n is 2, 2 minus 1 is 1, 1 times 2. When n is 3, 3 minus 1 is 2 times 3. So it works. So this is the equation or rule for the sequence. Now we're going to talk about series. A series is when the terms of a sequence are added together. That's the series. And so we could have finite series or infinite series, just like the sequence. Now, just note that a series has addition symbol between two terms, because it is the sum of sequence. If we get rid of the addition symbols and put comma, then that becomes a sequence. Now, when we talk about series, we have a summation notation, which is this symbol right here. And that is called the sigma notation. And it comes from the Greek letter sigma. And that is the lower limit of summation, and that is the upper limit of summation. And we're going to take a look at some examples. So we have a summation from I equals 1 to 3 of 8i. So what will be the answer to this? Well, we're starting with the lower summation, which is 1. So instead of I, we're going to plug in 1. So we get 8 times 1 plus, what's the next term? Well, next number that comes after 1 is 2. So 2 times 8. And after 2, the next number that comes after 2 is 3. And notice, that is the upper limit. So we are going to stop at 8 times 3. If this was 4, then we need one more term, 8 times 4. Now all we got to do is add them up. 8 plus 16 plus 24, which is 48. So that is your final answer. Now notice, you have 3 terms here. That's because you're going from 1 to 3. It's like if I ask you how many terms are in this series, all you got to do is subtract upper minus lower and then add 1. That will give you the total number of terms for this series. What about this summation? The lower limit is 3 and upper limit is 7. So how many terms does this series contain? Well, again, it's going to be 7 minus 3, upper minus lower, and then add 1. So it's going to be 5. There are going to be 5 terms. In other words, you are adding 5 terms. So what will be the first term? You're starting from 3. So 3 squared is going to be 9. 9 minus 1 is 8. Plus, number after 3 is 4. 4 squared is 16. 16 minus 1 is 15. Plus, 5 squared, 25, minus 1, 24. 6 squared is 36, minus 1, 35. And finally, we're going up to 7. 7 squared is going to be 49. 49 minus 1 is 48. So we do have 5 terms. Now, what will be the sum of this? Well, let's add these two. You get 23. What about these two? You get 59. And then you have 48. Adding these two, you're going to get 82 plus 48. And 82 plus 48 is going to be 130. So answer to this will be 130. What about this one? The lower limit is 1 and upper limit is 5, and we have 2. Notice we don't have any variable to substitute. So what will be the first term? When I is 1, it's just going to be 2. What about when I is 2? It also is 2. When I is 3, it's just going to be 2 as well. And so 4. So you adding 2 plus 2 plus 2 plus 2 plus 2, which is the same thing as 2 times 5, and that's 10. And how are we going to rewrite this using summation notation? This is a series. So if you notice the pattern here, this is like 25 times 1 plus 25 times 2 plus 25 times 3 plus dot 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 plus 25 times 10. So what you could do is, it looks like this is going to be 25n, where is the lower limit is going to be, it's going to start from n equals 1, and then it's going to go all the way up to 10. So this is how you rewrite the series using sigma notation. Now this series is infinite series. It doesn't stop. So we know that the upper limit will be infinity. If you take a look at the pattern, the denominator is always 1 greater than the numerator. So if we let k represent the numerator, the denominator will be k plus 1. And the lower limit will be k equals 1. So plug in 1, you get 1 over 2. When k is 2, you get 2 over 3, and so forth. But it doesn't stop, so the upper limit will be infinity. So this is an infinite series. Now instead of k, you could have used the I or n. It doesn't matter which one, which variable you use, but you got to be consistent. And when I say be consistent, it means all the variables, the lower limit, and all the variables inside has to be the same variable.